Okay, so what David and I were trying to do is figuring out how one would create a formal meaning for Wikidata. Now, Wikidata is a knowledge graph with some extra stuff. And if it was just a knowledge graph, then the work from Dresden on Mars, Marple would be fine. But there are a bunch of things we had to consider: the particular, slightly unusual Wikidata data types, the pervasive use of qualifiers, and these are sort of things like start times, end times, all sorts of stuff that are added to facts. And if you don't have some way of handling them, in a macro-like fashion, your rules your inference rules and everything else just gets incredibly big. So we added essentially a way of handling qualifiers in a default fashion. And then what you have is you can then write ontology inference rules in your standard way that subclass is transitive. And you can actually then say, oh, okay, now we have a single model that provides the meaning of Wikidata. We take the facts in Wikidata, we throw in a bunch of ontology rules, and we take the consequences, and that's the meaning of Wikidata that people actually should be using, as opposed to the data that's just sitting there. One nice benefit is now we have a single model. We can actually write general FOL queries that will handle the constraints that are in Wikidata. And so their violations are constraint reports. The result is, if you're careful, and you have to be careful in a number of areas, you can get what you might call reasonable computational properties, i.e. Everything is polynomial in the size of the Wikidata knowledge, in the Wikidata fact base. So that's what we did. We get Wikidata out of this, as long as you fill in all the dot the I's and cross the T's. And you can actually extend Wikidata in nice ways. For example, adding recognition conditions for classes like woman without adding much to the computational problems. So that's what we did. You can come talk to us at the poster session.